Greetings, stargazers. Is it really true? Imagine a big astronomical event that is visible even in broad daytime, casting shadows on Earth. That's the show that the constellation Orion may be about to provide us with. Betelgeuse, a star that is suspiciously behaving, is pointing to the possibility of a supernova explosion that will light up our sky like never before. But when will Betelgeuse explode as a supernova, and how will scientists describe it? What mysteries could this extraordinary occasion reveal? Come along as we delve deeply into the facts of Betelgeuse's true situation and the potential effects it may have on Earth, and even the entire solar system. Betelgeuse is a red supergiant star, one of the brightest stars known to science, with a brilliance that is over 100,000 times that of our Sun. It is situated in the constellation Orion, some 650 light-years from Earth. However, why is this red giant so important to us? Betelgeuse, however, is distinguished not just by its brightness, but also by its cultural significance and historical background. Betelgeuse, named after the Arabic term Yad al-Za, which translates to the hand of Orion, has long been recognized and recorded by ancient cultures. With its crimson tinge that sets it apart from other stars in the Orion constellation, it has served as a guide for travelers and a source of wonder for stargazers. Is it possible for one star to outweigh the entire solar system? To put Betelgeuse's immense size into perspective, consider that if it were our Sun, its edges would reach all the way to Jupiter. How is it possible for one star to grow to such enormous sizes? Although Betelgeuse is only 10 million years old, it is predicted to have a shorter lifespan than other stars due to its immense size, which causes it to devour its materials at a far faster pace than our Sun, which is 5 billion years old. Now, this massive celestial body is approaching the conclusion of its life cycle. Its volume is big enough to hold over 1 billion of our suns. When stars of that size approach nightfall, they don't just go out quietly. Rather, they explode with a brightness and energy that is incomprehensible to humans. A phenomenon like this may eclipse the brightness of a whole galaxy, illuminating large swaths of space with its brilliant shadows. This close of a supernova explosion was last seen on Earth in 1964, long before the development of modern telescopes. The last supernova to be seen witnessed with the naked eye in our Milky Way galaxy was this event, also referred to as Kepler's supernova. Brighter than any other star in the night sky, it was visible for more than 18 months, and for some weeks it was also visible during the day. What secrets can we learn from these stellar remnants? This new star's emergence was recorded in ancient documents from several civilizations, including Chinese and European astronomers. Surprisingly, modern telescopes are still able to view the explosion's aftereffects in the shape of a growing cloud of debris, which provides us with information on the terrible demise of huge stars. Supernovae are rare events in Earth's history, but picture a star explosion that is so bright it can be seen during the day and cast shadows on the planet similar to that of a full moon. Such massive explosion would charge our atmosphere with radiation, which might affect satellite operations and possibly even the climate. Betelgeuse seems to be preparing for a spectacular show, judging by its erratic dimming patterns. Is one of the most spectacular things in the history of the cosmos about to happen? Astronomers have discovered something shocking. Betelgeuse saw a dramatic change that caught the interest of astronomers and fans all around the world between October 2019 and early 2023. Known as the Great Dimming, the star's brilliance started to drastically decline after being constant for centuries. When Betelgeuse was compared to other stars in the Orion constellation, even inexperienced observers could clearly see this abrupt shift. It implies that we could be experiencing its supernova explosion in a matter of decades or even fewer, rather than merely centuries. Many assumed that the anomaly had ended when astronomical observations in April 2023 showed that Betelgeuse had reverted to its usual brightness levels. Then, in a shocking turn of events, Betelgeuse's brilliance increased by an astounding 50% in the months that followed. Though characteristic of variable stars, such significant variations were unprecedented for a star such as Betelgeuse, which had mostly shown cycles of predictable luminosity. Discussions on the star's immediate future were sparked by the abrupt and powerful increase in brightness that brought the star back into the public eye. But why was the brightness suddenly changing? Why did one of the most well-known stars in our sky, Betelgeuse, toss a curveball to celestial affairs so abruptly. Stars are dynamic beings with life cycles, activities, and secrets of their own. They are more than just sparkling dots in our night sky. Similar to the cycles of Earth seasons, periodic fluctuations in brightness are predictable for many celestial bodies. Over the course of its star lifespan, Betelgeuse exhibited a very stable 400-day brightness cycle. But with the enormous darkening, it appeared to go against its usual course, casting doubt on our understanding of the cosmic occurrences overhead. I know what you're thinking. Are we about to witness a galactic revelation? Although the precise causes of Betelgeuse's anomalies are still being looked into, an intriguing possibility has come to light. This idea, which focuses on mass ejection and star activity, offers an interesting scenario. Imagine Betelgeuse as a massive celestial volcano that is erupting and ejecting a significant portion of its stuff into space. Previous Hubble Space Telescope scans showed that Betelgeuse had previously ejected a massive amount of its surface material into space. This expulsion was a tremendous event that amounted to several times the mass of our Moon, 400 billion times the mass usually ejected during similar solar occurrences. A dense dust cloud may build around the star as a result of such events, altering its apparent brightness and momentarily making it more difficult to detect. Then the curtain lifted as this dust started to scatter or was forced away by the pressure of the star's radiation. This may explain why it later returned to normal brightness levels. In any case, these recent occurrences point to a star who may yet surprise us. There are many who believe that Betelgeuse is nearing its end of its life. A supernova event, an incredible outburst of energy that can momentarily outshine an entire galaxy. When the star's core abruptly changes, this phenomena happens. These alterations can occur when a star absorbs excessive amounts of material from nearby stars, or, in the case of Betelgeuse, when its nuclear fuel runs out and its mass cascades into the core, causing a catastrophic collapse. But what ultimately brings down a big star such as Betelgeuse? Stars like Betelgeuse ignite their journey by burning hydrogen in their cores. Stars like Betelgeuse are born from the gravitational collapse of gas within molecular clouds. A star's life begins with this first stage, called the main sequence stage, which lasts for millions of years. Stars change and adopt new energy sources as their hydrogen reserves diminish. In the case of Betelgeuse, helium starts to burn when the hydrogen runs out, forming carbon and oxygen. The star expands into a red giant during this change from the main sequence phase to the helium-burning phase. The star expands further over time and enters different burning stages, each of which is marked by the fusion of increasingly heavier elements as its helium reserves run out. These changes occur more quickly in larger stars due to the strong gravitational forces at work. Then, when iron begins to develop at the core, the dramatic moment occurs. Iron does not release energy when fused, in contrast to lighter materials, hence the energy generated is insufficient to withstand the star's own crushing gravity. A supernova's explosive force is produced when a star explodes due to its immense rebound after expanding to an enormous extent and causing an implosion. So, is Betelgeuse waiting its turn, or is it about to explode? According to recent research from Tohoku University in Japan, the star may currently be in its carbon-burning phase. According to lead researcher Hayduk, a few decades after its carbon supplies run out, the core might collapse. Not all scientists, though, agree. Conflicting research from Hungary's Konkoly Observatory suggests that Betelgeuse may still be in the early stages of helium burning. Despite these disagreements, astronomers do believe that Betelgeuse will eventually become the next supernova in the Milky Way. However, determining the exact timing of this event is still up in the air, with predictions ranging from a few decades to 100,000 years. One thing that has not been disputed in all of these scientific discussions and conjectures on Betelgeuse's destiny is the nature of our observations itself. There's a subtle paradox in the vastness of space that we often miss when we glance up. The basic properties of time and light in our enormous universe are the source of this dilemma. The light from stars and other celestial bodies travels a great distance before it reaches our eyes. For example, even though light travels at an incredible speed of 186,282 miles per second, it still has limitations. As a result, light from far-off stars and galaxies takes a very long time to reach us via the vastness of space. When you look at Betelgeuse, you are actually looking at a show that took place 650 years ago. To put things in context, the Renaissance was only getting underway when this particular light began its trek toward Earth, and explorers like Marco Polo was leaving his imprint on history. Every observation we make of Betelgeuse provides us with insights into its distant past, much like peering into a cosmic time capsule. For the sake of argument, if Betelgeuse had already burst into a spectacular supernova, we would not know about it for another 650 years. Therefore, even while we talk about and forecast its impending supernova, this enormous event may have already occurred elsewhere in the vast cosmos. All we can do is wait for it to travel across space and time until it reaches our anxious telescopes. The astronomical world has been enthralled with the recent discoveries surrounding Betelgeuse, drawing parallels to another extraordinary find from earlier this year. SN 2023X. A galaxy close to the Milky Way was the site of a newly discovered supernova, which served as a reminder to many of the universe's intriguing dynamics and unpredictable nature. Several million light-years away, SN 2023X was a singular object that briefly outshone its home galaxy with an incredible flash of brilliance. But its striking similarity to what many believe would be Betelgeuse's end was what really piqued the imagination of both experts and lay onlookers. The explosion's spectrum, intensity, and aftermath provided a fascinating window into the processes that these huge stars go through as their life cycles come to a close. For a lot of people, SN 2023X was a taste of what could happen should Betelgeuse meet its cataclysmic end. The relationship between these two astronomical occurrences highlights a more general idea regarding the interdependence of the universe. These celestial events, which can include a far-off supernova like SN 2023X or a nearby star like Betelgeuse, serve as a constant reminder of how dynamic and ever-changing space is. Beyond the material and empirical, the explosion would have a significant impact on human civilization. The sky, which had been studied and worshipped for millennia, will eventually alter, inspiring contemplations on ephemerality, the vastness of cosmic time, and our role in it. These cosmic marvels serve as a constant reminder of the fleeting nature of life and our never-ending quest to understand the vast beyond. We appreciate you seeing this space theory episode. You won't believe the video that appears on your screen, so don't miss it.